Okay, this video is going to work through the process of how to get the quantities for a bridge structure. This is specifically a bridge based on Oklahoma Department of Transportation spec sheets. And so it's fairly specific to that, but it'll probably give you the general idea of most places. So we have just a generic bridge. We're going to be putting in a 55-foot type 2 PC beam bridge that's on a 30-degree skew to fit our creek channel. This is just the generic bridge sheet, plan and profile kind of sheet within our plans. But we include, here we have just the full overall quantities, but we try to give an idea of some of these other quantities as well in here, and some other features like the geotech report. So just to get started here, so within this sheet, one of the first things we do is just kind of put in our geotech data. So we have borings we have the geotech take borings on each side of the bridge, and this is specifically to get an idea of how deep we need to drive the piles that are tied into the wing and abutment structures. And so they essentially give us a soil profile of that area and then give us an estimated depth that we need to get to. So I'll pull that up here. So this is from the geotech report. They'll basically have a boring on each side and they'll show you where it is, and then they give you an estimated pile tip depth, and then kind of about where bedrock is, and then you can scroll down, and they'll have boring logs. And essentially this is what we replicate within the sheet. It just kind of tells you for each stratum there, the elevations and the type of soil encountered there. So essentially that's what we're doing here, and we just copy that on each side just to get an idea. And then we go ahead and put those estimated pile tips there. So going from that, we'll work through essentially the spec sheets that are needed to complete the full amount of quantities for this bridge. And there's quite a few of them, and it's a little confusing at the start, but once you work through them, it kind of starts to make sense a little bit. The one thing you will need to know for all this, which you should know from your design, essentially is the deck slab, the top of the slab elevation. So we have that marked here. Okay, so just kind of a walkthrough of the sheets you'll need. So again, we have PC beam details type 2 50-foot span. Okay, and it's really hard to kind of keep track of all these. Just let me show you real quick. The website you get all these at is the ODOT bridge standards. We use the county bridge for this because it's a county bridge, but you can pick which standards you want to use. So we're going to go to county bridge, and you can see all the way through. It's got all the different sections for abutment, superstructure, all this, and it's kind of coded here. And so it takes a little while to work through all of these. But essentially you have a few different details you can pick from when you're looking at a bridge. So you can look at essentially the centerline roadway width, which you'll see here it can either be 26 or 32 feet generally. And then you'll have this C, and there's either a C or an I depending on whether this is a conventional bridge or an integral bridge. And then you'll have this SK for a skew. So skews generally either 0 or 30 degrees. So you can see these are all SK0, and then now we can get down to the SK30s. But again, all of those need to line up with your specific bridge type for each of the sheets. So it's a little complicated to work through here. And then you have different PC beam types, and then there's also rolled beams. So we've collected all the sheets, and essentially what we're going to need to complete all our quantity calculations, we will need the beam details sheet, so the PC beam detail sheets, and this gives us the length of the beam. So note here, we zoom in, we'll come back to this, even though this is a 55 foot, that's what we call it, span, the length of the beam isn't exactly 55 feet, but essentially that's a rounded number. But that's the way we want to call it, a 55 foot span bridge, because that's how we reference it in all the sheets. Okay, so then we also have this one. It's a longitudinal section for the PC beams, but again, 32 foot clear roadway, conventional, and skewed 30 degrees. So just always double check and make sure these are all lining up. And we'll come back to this, but this basically gives us some extra information that we'll use to do some of the calculations. Within the quantities, you have a sheet that's the superstructure quantities, and this gives you the bulk of what your quantities are, and we'll go through this in just a minute. Again, check to make sure it's the right kind. This is for all PC beams, or I believe it's two different types. So we have for type 2 and type B, and a few different types. There will be different superstructure quantity sheets for type 3, type 4, other kinds of beams. Or actually, it's down in here. So for the longer the span, the different types of beams. And then we have our abutment details. So again, type 2 PC beams down here. And so we have a quantities sheet here, and there's two abutment details. We'll also need the second one to get a few measurements out of it. And then we have the wing details, okay, and we have quantities associated with that. So, just to start off working through our quantities, so just to get a general idea, first of all, we'll start with getting the just total length of the bridge, from essentially the back of the abutment, back face of the abutment, to the back face of the other abutment. So again, we have our PC beam details. So length of beam 54 foot 8 inches. Okay, and then we need to go secondly to the longitudinal section sheet. And if you look here, each one of these explains a different distance, but these up here are from abutments to piers and different types of piers. We want to keep working through. This is just a straight bridge, so we have here the length abutment to abutment. And this is mildly confusing here, because essentially what you have up here is it's the span length equals beam length plus this 5 foot 6 5/8 inches. But that, we'll note, is based off of this diagram, and it's showing this type 3 PC beam shown. Okay, and then all other PC beams are similar. But what we need to get out of this information, we don't want to use this number directly. This number corresponds to basically what is shown here. So for type 3 PC beams, we have this general idea. But the thing that's going to change, so we'll have the same, this is the end of our beam, and this is the gap between the end of the beam and the front face of the back wall of the abutment. Okay, so that's always going to be 1 foot 4 inches, no matter what type of abutment you have, what type of beams you have. What does change is this number here. So this 1 foot 5 5/16 inch, that's specifically related to type 3 PC beams. But it's not going to be the same. We're looking at a type 2 beam. So what we need to do, so we know we'll have our 1 foot 4 inches on each side here. So we need to go to the abutment details, specifically the second sheet, and we look at how wide the back wall is. So again, this is that front face, and so we have 1 foot 3 inches. So to get our total span length, we have 1 foot 3 inches plus the 1 foot 4 inches that we mentioned to get to the beam, then the total beam length, and then we essentially have those values on the other side. So this is on both sides. So you need to add 1 foot 3 inches times 2 plus 1 foot 4 inches times 2 to your span length. Okay, and then that'll get you your total length. All right, and so that's just a general idea there, of the total length of the bridge. So the next major thing is looking at the superstructure quantities, and this is fairly simple to work through. And so when you come in, it's just a general table, and so we're not looking at piers, so we just want to go abutment to abutment here. And so we need to find our length of the span, so we have 55 feet, and we're looking at a type 2 PC beam. Okay, so then we just follow all the way across here, and we can highlight that. Actually, well, let's not worry about that. We can just look at it. So then we have each of these categories, and that's our individual quantities, pay item quantities. And we just work our way through all the way across. Okay, and then that's just straight up recorded, and that's per bridge. And so we don't have to worry about doing any further calculations here. So the superstructure quantities we can just put straight in. Okay. Now we have to look at abutment quantities. So we come to the abutment sheet, and so we have a summary of quantities for abutment. And you'll note here that it says summary of quantities for one abutment, but we have two abutments, one on each end of the bridge. Okay, so for every one of these quantities, we are going to have to multiply that by 2. And so that's kind of where you can get tricked up a little bit. And some of these quantities are going to be a pay item that is similar to or the same as something for the superstructure quantities, so we have to remember to add that onto that as well. Okay, we'll come back here to these piles, and we'll discuss that kind of separately in just a minute. But then, for the most part, you have all your quantities. So this non-perforated pipe under drain, generally we put that at about 100 feet, and that gives us enough length for almost any bridge to kind of just run the drain out. So essentially you have the perforated pipe that goes underneath the abutment to drain that area, and then we switch it to that drains into a non-perforated pipe to get it the rest of the way out, and generally just down to the creek bed. Okay, and so that takes care of all the abutment quantities. But then lastly we have wing quantities. So the wings come off of each side of the abutment. So there are 4 wings. And so again, we have quantities listed here for one wing. Okay, so now the trick is we have to take each of these quantities and multiply them by 4. Okay, and again, there are piles within that quantity as well that we'll need to calculate separately. So let's go back to the abutment sheet and just take a look. So we have each one of these H looking things is essentially an I, kind of like an I-beam pile. So these are driven into the ground and then tied into the concrete in both the wings and the abutment to hold the bridge basically stable on the ends, hold the abutment stable. So on the wings, and I think if we look at the separate sheet, so if we look at the abutment, there are 2 different types of piles. There are straight piles and angular piles within the abutment, and then the wing piles are straight piles, which you can see here on the wing detail sheet. Okay, so the wing piles are a separate type. They're the HP 10 by 42 piles, and on the abutment they're the HP 12 by 53 piles. Okay, so what we need to do from here is we need to figure out a couple different measurements. So we got from our geotech report it told us our estimated pile depth. So if we kind of just get an idea, go back to our schematic here. This is essentially what the piles are going to look like. We have one in the wing, we have our straight, and we have our angular pile in the abutment. And this is just a graphic, but they all go basically to the same depth, and this is our estimated pile tip elevation. Okay, so they're all going to come to this point, but they all start at a little bit different point here between the abutment and the wing. Okay, and so that's what we have to figure out. And then one of them is angular, so then we have to calculate that as an angular distance. So to look at our, going back to our abutment sheet here, and actually the second abutment sheet, so we need to know where the top of the pile is. So right here we can see this pile projection. Okay, and so it comes up 1 foot from the bottom of the abutment here, and so we can look here, and this measurement is essentially to the flat part, to the seat, the bridge seat. So we need to find out essentially what the elevation of the bridge seat is going to be able to find out what the elevation of the top of the pile is. And for that, we go back to our longitudinal section sheet, and actually and this is a little bit convoluted here, but we're looking for this H value. Okay, and so that's from the top of the slab to the bridge seat. Okay, so it'll tell you here, it's got this note 1, and it'll tell you dimensions from top of deck slab to bottom of the bearing assembly. Okay, that's the elevation we're looking for. So we know from our design what the top of our slab is. And then if we come in for H, you can see the schedule for dimension H, and we find the type of P-seam beam when we're type 2. And so now we're 4 foot 3 1/8 inch down to get to this seat. Okay, so we can calculate that bridge seat, but again we have to come back to our abutment detail and take that and drop it down. So now we have this 2 inches, and in the 2 feet 6 inches below the bridge seat, and then come back up 1 foot, and that's the top of our piles for our 12 by 53 piles. Okay, so for the straight piles, that's fairly simple to calculate. We go from the top of the pile straight down to the pile tip. Okay, and that's an easy calculation. For this angular pile, it gives us essentially a measurement here of the angle. So it gives us the two side lengths. So this is at a 2 to 12. Or essentially a 1 to 6. And so we can take that and calculate the angle. And so what we need to do here is take the top of the pile elevation and the bottom of the pile elevation, and we figure out the length of that using trigonometry, basically just Pythagorean's theorem. So we can get the top and bottom, and then we use a factor of 6, divide that by 6, get this number here, and then we can use Pythagorean's theorem to get this, the length of this angular pile. Okay, and similarly for the wing, we need to come in and figure out where the top of the pile sits. Okay, so here we look, this spot right here is our deck slab, and then here we have the top of the pile projection. So we go 4 feet down here and then 1 foot back up, and so this is essentially 3 feet below our deck is the top of the pile for the wing. And again, we have the depth to the estimated pile tip from the geotech report. So we can easily figure out the length of each pile. The main thing to remember is multiplying by how many piles there are total. So we take a look at each of the abutments. For each abutment, we have 3 12 by 53 straight piles and 2 12 by 53 angular piles. Okay. Now again, this is one abutment, so you'll need to take those and divide or multiply by 2. So there will be 4 angular piles, 3 or 6 straight piles. Likewise, you have one pile that's 10 by 42 for each wing, and so there will be 4 of those total that you'll have to calculate. Okay, and then once you've worked through all of that, so this is kind of breaking it out, you'll have all your different pay items and quantities and units, and then basically what I like to do to help keep it straightforward is you split these up, which ones came from the superstructure, which ones from the abutment, and which ones from the wing, and so that's easier to go back in and check any errors you had. Okay, and again, and then we just come in and fill that in, and we can link our table right in here, and that pretty much makes up our bridge quantity sheet. So that's it for this video. Thanks.